Salvation of energy. It is found that different ionic compounds electrolytes tend to dissolve to different extent in a solvent. When we add an ionic solid to a solvent, the cations and anions present in this ionic solid are respectively surrounded by the negative and positive ends of the solvent molecules. Surrounding solvent molecules partly neutralize the charge of the ions. Okay? Thus, ion dipole interaction. Ion dipole interaction which causes loose combination between the ion and solvent molecules is known as salvation. If the solvent is water, it is termed as hydration. Thus, salvation hydration energy refers to the energy released when 1 mole of the ions are salvated, okay, hydrated. Okay, sodium positive ions in gaseous state 1 mole plus water, arrow mark of sodium positive ions 1 mole of hydrated ions plus delta Hy hydration energy. Okay, hydration energy. Thus, salvation energy is the energy. Thus, salvation energy. Energy. Salvation energy is the energy. Salvation energy is the energy released due to interaction between the ions and the solvent molecules. Okay, the salvation energy is the energy released due to interaction between ion and the solvent molecules. Okay, this is sodium positive ions, negative positive. This is positive, negative. This is positive, negative, and this is negative, positive. This is positive, negative, this is negative, positive. Okay? And this is chlorine ion. Okay, negative positive, this is negative positive, this is positive negative, this is positive negative, this is positive negative, and this is positive negative. This is chlorine ion. Okay, then salvation hydration of sodium molecules. This is salvation hydration of sodium chloride molecules, that is sodium positive ion, chlorine negative ion plus NH2O, arrow mark of sodium positive ion H2O, N plus chlorine negative ion H2O, N plus delta Hy. Okay, delta Hy are sodium positive ions plus chlorine negative ions plus delta Hy. That is delta Hy is hydration energy. Hydration energy. Okay, what is hydration energy and how to work the hydration energy? Hydration energy, 1 minute. Hydration energy. What is hydration energy? Hydration energy. The enthalpy change in the conversion of 1 mole of gaseous ion to aqueous ion is called hydration energy. Okay, the enthalpy change in the conversion of 1 mole of a gaseous ion to aqueous ion is called hydration energy. Okay, the enthalpy change in the conversion of 1 mole of a gaseous ion to aqueous ion is called hydration energy. Okay, M in gaseous ion is M positive in aqueous ion plus Q. Okay, that is delta Hy equal to minus Q. That means the hydration energy is minus Q. Heat is released in the hydration of ion. It is given by the mathematical expression as delta Hy hydration ion in the form of heat is minus Ze square upon 2 Re 1 minus 1 upon D, where delta Hy is hydration energy. And E equal to charge of the electron. And D equal to dielectric constant of the medium. D is dielectric constant of the medium. And Re, distance between the center of the ions, distance between the center of the ion and the center of gravity of the polar solvent molecules. Okay. Delta Hy hydration energy is charge of the electron, and D dielectric constant of the medium. R is distance between the center of the ion and the center of the gravity of the polar solvent molecules. Okay. Next, factor affecting salvation or hydration energy. Factor affecting salvation or hydration energy. 1 minute. Factor affecting 1 minute. Factor affecting salvation, hydration energy. Factor affecting salvation, hydration energy. These are the factors which affect salvation. First, radii of the ion. Radii of the iron, radii of the iron. Smaller the radii of the iron, smaller radii of the iron. Smaller the radii of the iron, smaller the radii of the iron, greater is the salvation. Greater is the salvation. Greater is the salvation. Okay? And hydration energy. Thus, delta Hy of K positive ion is greater than sodium positive ion since radius of sodium positive ions is less than potassium positive ions. Okay? And delta Hy hydration energy of chlorine ion is less than fluorine ion as the radius of fluorine ion is less than chlorine ion. Next is the effective nuclear charge. Second, effective nuclear charge. Effective nuclear charge. If the radius of the cation and the charge remains the same, greater is the Z, greater is salvation hydration energy. Okay? That means if the radius of the cation, radius of the cation and charge remains the same, greater is Z. Z conjugate, then greater is salvation, then greater is salvation energy. That means delta Hy of silver positive ions is greater than delta Hy of potassium positive ions. Okay? Next, charge of the ion. Third point, charge of the ion. Okay? Charge of the ion. Greater is the charge of the ion, greater is the hydration energy. Greater is the charge ions. Greater is the charge of the ions greater is the hydration energy. Greater is the hydration energy. That means delta Hy of sodium positive ions is less than delta Hy of the calcium positive double ions. Okay? Thus, greater is the charge of the ions, greater is the hydration energy. Greater is the charge ions, greater is the hydration energy. Next heading is solubility of ionic solids. Okay?